My name is Scott Ritchie, and I can solve a Rubik's Cube in 44 seconds.
My name is Brenner Herjavac, and I can solve a Rubik's Cube in a minute 30.
My name is Mitchell Cheeseman, and I can solve a Rubik's Cube in 1 minute and 30 seconds.
My name is Eric Lineback, and I can solve the Rubik's Cube in 10 seconds.
Scott Ritchie is so good at the Rubik's Cube, he can solve it with a quick stroke of his mustache.
Brendan is so talented, he can solve a cube one-handed while doing push-ups.
Good.
Whenever Mitch faces too tough a challenge, he simplifies it to his own liking.
Studies have shown that there is approximately a 16.67% chance of scoring a date by solving a cube. If I could solve this cube in 10 seconds, would you consider going out with me?
No.
No.
No. No.
No. Yes.
If Eric averages 10 second solves and has a standard deviation of 0.8 seconds per solve, a solve of under 9 seconds will therefore have a Z-score of 1.25. Knowing this, we can calculate that there is approximately a 10% chance of him getting an average time of under 9 seconds during a competition.
There is a Laurier Rubik's Cube Club with over 50 registered members and still growing. Given that someone is a student at Laurier, the probability of them being in the Laurier Rubik's Cube Club is 1 in 240.
Over 350 million cubes have been sold worldwide since 1980.
The more you know.
The current world record is 5.66 seconds, held by Felix Zemdegs of Australia. We have established a clear correlation between solving fast and being Australian, but we cannot prove causation.
Cubers use the standard deviation to identify how consistent their solves are. The higher the standard deviation, the worse you are at cubing.
At a Rubik's Cube competition, competitors are ranked after completing 5 solves. The fastest and slowest times are then removed, so the rankings depend on the mean of the remaining 3.
The original Rubik's Cube has 8 corners and 12 edges. There are 8 factorial ways to arrange the corner cubes. 7 can be oriented independently, and the orientation of the 8th depends on the preceding 7, giving 3 to the 7 possibilities. There are 12 factorial over 2 ways to arrange the edges, since an even permutation of the corners implies an even permutation of the edges as well. 11 edges can be flipped independently, with the flip of the 12th depending on the preceding ones, giving 2 to the 11 possibilities. If we multiply these figures together, we get a total number of 43 quintillion, 252 quadrillion, 3 trillion, 274 billion, 489 million, 856,000 configurations of the Rubik's Cube. 3, 2, 1, go. 3, 2, 1, go.